it for you today, but next time, basically in 3 hours, if you want to restart it, it will take a couple of minutes to spin up. Okay, so don't worry about that. It's normal. It can take up to 15 minutes to populate. So don't worry. This is a perfectly normal behavior. Okay, let's start the pipeline. So before fully pushing the application, our turnkey racing game, we want to try different types of pipelines and see which one fits our needs, which one is perfect for our product. So this is our very first step, and we will start a pipeline, define it, and see how it runs. Let's see what a pipeline is and how we can configure it. Basically, a pipeline is what you see on screen right now. It is defined in a file. The name doesn't appear there. A file named GitLab ci.yaml. And in that file, you will see a list of jobs. The job here on line 18 is named production, associated to a stage on line 19. Okay, and then you will see basically 1, 2, or 3 instructions at the same level of the stage. The first one is the before script, which is a set of commands which are needed to execute your script. Basically, that's a set of commands that you want to run for the setup of your script, and they run in the same shell as your script. So the script is the main body of your job, and the before script is the setup of that body, which means that if the before script fails, the script cannot run. Okay, and then you have an after script, which runs in a separate shell and has no impact on the execution of your pipeline. Basically, the after script might fail without failing your job. Okay, there is no direct relationship between the execution code of your after script and the result of your job. Okay, then once we have a pipeline, you will see it being executed. Okay, and this is a vision that we provide here that you can see on the screen. You have different color and different logo, basically, for every job. Here you can see one stage, which is build, and another stage, which is test. And in the first stage, you have one job, while in the second stage, you have 2 jobs. Okay, the 2 jobs are called quality and unit test in that case. And here we see that there is a gray dot in front of the jobs in the test stage, meaning that the jobs are waiting for a dependent jobs to be completed. And in this case, you can see the relationship with these gray lines, meaning that we have a relationship between the build stage, actually the build app job, and the 2 jobs in the stage, in the test stage. All right, so the build app is running. This is why we have a blue dot, blue logo in front of it, and then the other ones are waiting for its full execution. Okay, and here, what is important, both jobs are running in parallel. So each stage is executed sequentially, and then each job in a stage is executed in parallel. Okay, which makes things much more faster when you run your whole pipeline. Another keyword that you might be interested when you will write your jobs is the needs keyword, which is used basically to start jobs earlier. It means that when you have a needs keyword, you can define when a job will start, and you say the list of job it depends on. Without the needs keywords, you are just running each stage sequentially. With the needs keywords, you will run the jobs in the order that you define. So this is really up to you. You can use either only the needs keywords, only stages, or combine both to execute the pipeline the way you want. All right. And here we can see that there is nothing in the needs keyword, meaning that the code quality job, which is defined here, has no dependencies. So it starts as soon as the pipeline starts, actually. All right. And as I said, you can use either stage or needs. And now with the most recent versions of GitLab, you can get rid of the stage keyword and use only the needs keywords to construct and build your own workflow from one job to the other one. Okay, which makes a pipeline stageless, what we call stageless here at GitLab. And so you just implicitly define the way your jobs are executed to eventually make them faster. All right. Then you will also see a tag keyword when you define a job, which is here. The tag keyword is used to define which runners are used to execute your job. What a runner is. A runner is the software that will execute your job. So basically all of your jobs will run in runners, and they can run in different runners or in the same runner. It's not, there is no constraints on that. You choose with the tag keyword, you just list all the runners that you want to use or that you can use to run a job. So basically the tags that you are using here should match the tags that the runner have. And as soon as you have a runner with a tag matching the tag defining your job, the job will be executed. This also means that even if what we have seen in the previous screen here, we have a dependency between jobs, sometimes you will still be on the gray dot just because no runner is available. It just means that you need to wait for a runner to be available, and this is not a problem. Until you got a red dot, and there is no problem in the execution of your pipeline. It just takes time to execute. Okay, that's totally normal. Okay, unless it's failed, then it's working. All right. So what we are going to do now is to give you the hand. Normally, I've seen some questions in the chat that Sujivan and James are answering.
Olivier, it's James here. Just to chime in here, we're just looking in the background. There does seem to be a couple of issues getting people onto Instruct. We can just wait a few more minutes. We're working technically to see what's happening in the background. So apologies to those that are not getting access to Instruct just yet. You will be able to catch up, and this content will be available also afterwards. You can follow through in your own time as well. But bear with us. For those that do have access, I guess we can follow along with Olivier when he continues. Thanks, Olivier.
You're welcome. Thank you, James. So what I will do is just to do that with you live. I've got here, and maybe I will have the same problem as you. So this is the first section in the Instruct. And so the first instruction regards importing a code that we share with you. This code will be available anytime for the next weeks, months, years, whatever. This is fully accessible. And what we are going to do here is to import that code in your group. So we can use that base to run all the stages and all the steps that we want to go through during this workshop. So the instruction says go to that URL. Okay, click on the fork link. Then select the namespace where you want to fork. The easiest thing is to copy the name of your namespace. Just copy that and paste here in the namespace in the drop-down list. Otherwise, you may waste a lot of time trying to find your group. But if you copy paste, it should be very efficient for you since this name is unique. Okay, you can leave and you must leave actually the project slug because we are going to rely on that one for the next steps. Yes, we can make it a bit bigger. Okay, please tell me, Sahil, if this is big enough for you. Excellent. So we are going to fork the repository. Just click on that blue button. The forking is in progress. Basically, what fork means in the Git vocabulary, to fork a repository means to copy it, basically. Okay, so you are copying all the source code from the fork source to the fork destination. And so now in my group, which is here, I can see it in the breadcrumb. My group, I have the workshop project, which is the one that I have just forked. Okay, and in that project, what instruct tells me to do once the project is forked is to remove the fork relationship. This is necessary because otherwise you will have some relationship with the source, which might have some impact for you when you are doing the different labs. So let's go there. They say go to settings, general. I'm going to settings in the left menu, then on general. And here, if you scroll down, advanced, you can expand the advanced. And here you have a section dedicated to removing the fork relationship. And you just need to click on that red button. Why is it red? Just because when you have broken the relationship with your fork, you cannot build it again. So this is exactly what we want. Here, I'm just copy and paste the name of my project to confirm. And now I don't have any relationship anymore. Okay, so this was the step one. I have removed my fork relationship, and now we are going to create the starting pipeline. Okay, the instruction says, click on workshop project in top left menu, okay, and go ahead to the file .gitlab CI YAML that I was talking earlier to see it, and go to the pipeline editor. So I'm going to my project overview. I can see here my file, which defines my pipeline. And here in the build section, I can find my pipeline editor here. Don't worry, being late, it's not a problem. If you if you are late, it's not a problem. We will have some time at the end of every section, and in all cases, you will have time to complete the workshop again later on today or tomorrow. You have 48 hours to do that. So just the instruct says you have to go to settings, general. Here, settings and general in the left menu, and then at the very bottom, you can remove the relationship, the fork relationship. It was here and it's no longer here for me since I have removed it. Okay. So back in the pipeline editor, I can see here and I can visualize my pipeline, and it says that there is something incorrect, and your job now is to fix that. All right. Okay, we can see that we have two different stages defined, a base node image and a number of test jobs. Okay, we can also see that the configuration is broken, and we are going to fix that. This is what the whole goal of this lab. So we can do. Okay, so I'm leaving you a bit of time to go through this step, and I will go through it within a couple of minutes with you all for those who haven't had time to finish, so you can see it live.
Olivia, if you may just expand that step one, a few people who can't see instruct would like just to see the instructions, that'd be great. Fantastic, thank you.
Right, yes, sorry about that. Yeah, you have everything on screen, sorry about that.
No worries.
And maybe I can zoom in here also. Yeah, it should be even easier to read.
Perfect, especially for someone in my age.
We have the same age, James.
Shh, it's a secret.
So yeah, just for those who can't access Instruct, don't worry about that. We are working on the back to fix that. you are seeing all the instructions live on screen, and the infrastructure which needs to be provisioned is needed only for the second part of the workshop, which is driven by Ted. So basically, for the 3 or 4 first sections, can't remember, 4, I guess, you can follow everything on my screen and just use the GitLab account. GitLab is working perfectly fine. So you can just use your GitLab account, your GitLab group, and do everything in GitLab with the instructions on my screen. Okay, maybe I can answer live some questions I'm seeing. You should not change the name of the project. Simply fork it, find the namespace, which is basically your group name, okay, that you can copy and paste. Your group name appears here in the breadcrumb. So you can just copy and paste it. When you are forking, it appears here also if you are on your group, it's the name of your group, but please do not change the name of the project. Otherwise, you will have some failures later. Mitro, if you have changed it, there are 2 things to take into account: the name of the project and the slug, and both there are they are changed. There are 2 ways to change them independently. So I can't answer to you. It really depends on what you have done. So if you have only changed the name and not the slug, it may have some impact. Okay, back on the instructions. Sorry. Okay, I'm leaving a couple of minutes more, and then we'll move on to the next section. I will go through the step 2 and we'll move on to the next section. Okay, maybe I can ask you to raise your hand when you are done, so I can see if many people have done, and we can move on. Oh, many hands are rising. That's cool. Excellent. Okay, so I see most of you have finished this first workshop, so I'll just finish it. So for those who haven't had the opportunity to see it. So here in the pipeline, I can go here in the visualize. So I'm back so everybody sees. I'm in my project here. I can go in the build section in my menu and then in the pipeline editor here. And in the pipeline editor, okay, I can click here on visualize and see that there is a problem. Okay, your syntax is invalid. And I can then go, it advises me to go to the validate tab. Okay, and I can see here at the top of my page that there is a problem with the code quality job. The chosen stage does not exist. If I go back to the edit section, I can look for my quality job, which is here, and the stage is fake stage, which is not defined at the top of my pipeline editor. Okay, my pipeline definitions. I only have two stages, build and test. So what I will do is to change that stage to test. Okay, changed stage to test. All right, and then I'm committing the changes. Okay, the pipeline syntax is correct. I can now visualize my pipeline. Okay, everything seems valid. Okay, so no problem. And I can go here still in my build entry of the left menu. I can go in the pipeline section and see that I've got a pipeline running. I can click on that pipeline either on the status or on the ID of the pipeline. And I will see things that are running. So I've got my build app, my test, my code quality, and my unit test job. All of them are running. And I can see here the job dependencies, and I have no job dependencies in that case. We'll see job dependencies later on today. But right now I can see that everything is built concurrently, is run concurrently. All right. And once I've done that, the section is finished and we can move on to the next one. So let's go back here to the section 2, caching rules and failures. So now in our Tanuki game company, we have demonstrated that we can build things and automate the test. We have implemented a first pipeline, but the other members of the company are complaining about the time it takes and wants pipeline to be faster and more resilient. We are going to leverage GitLab to use the caching to cache result from one job to use as input for the next jobs. Okay, and this is what we are going to do. Basically, the order of execution for a job or a pipeline, actually the pipeline starts, the first job starts, okay? Before script is executed, this is what we have seen at the very beginning of the previous section. Then the script is executed, the after script is executed, and once all these 2 shell and 3 scripts are finished, we are going to cache things. So basically here we are going to cache the vendor directory, but you can obviously define whatever you want to cache, which will be zipped in a cache.zip file. Okay, this file is then saved in a directory based on the runner settings, and the cache key, we will see that in detail, don't worry. And then the job B runs, and what it does, it first starts with extracting the cache if it found some cache. Okay, if no cache exists, well, it just follows the executions. And then once again, you see the before script, script after script, and so on and so forth, and then your pipeline finishes. All right. So how do we set up all of this? We have here a job A, okay, which has a script. It basically creates a vendor directory and create a file in that vendor directory. We have an after script, which failure has no impact on the pipeline, as we already said. And we have here a definition of the cache for that job, which says what is the key for the cache. The key is build cache, and what is the path we want to cache. So this instruction says everything that is in this directory must be put in my zip corresponding to my cache, and that zip will be related to that key. Okay. And then in my job 2, I define the cache that I want to use. Okay. And with that cache defined, then my script will run and it will load that cache and my file here that has been created in job A, and we'll just cat the file basically here. So very basic job, but it demonstrates what the cache does. Okay, so basically it helps you to, for example, download dependencies. If you are doing Java or NPM, you may be aware of the npm install or the maven install steps, which downloads the internet basically. And so you can do that in a job and then reuse what has been downloaded already for the next jobs, for the test, the packaging, and so on and so forth. Right? You don't need to download it again and again and again at every single step of your pipeline. All right. In parallel to that, what we want to do also is to add an allow failure. The allow failure instructions says, okay, I am defining a job and I agree that this job may fail. It won't impact my delivery, or it won't impact my next stages. Okay, so basically a unit test, you may agree to fail on that specific job, and you just need to enter the allow failure true instructions in your job to make it ready to fail. Okay, and that is basically everything that we need to know about the allow failure. This is as simple as that. Then we also have a set of rules that we want to define, or that we can define on a job to improve it, or to add some conditions on these on the jobs. So the rules are basically something that you wanna liberate to add conditions on the execution of your job. So there are many clauses, operators, attributes, and when options that you can add together or not on your rules, and each rules will be executed sequentially. So you can have a clause with the if or changes or exist to define when to trigger a job. It will trigger if something, or if some changes, or if a file exists. Okay, you will use some operators to define if it's okay or not okay. Basically, these are the shell operators, very basic ones. Then you have some attributes to define if you want to run your job later with a when. If you say when delayed, then you must define a start in, so you can delay a job execution by 5 minutes, 5 hours, or whatever. This might be very useful. For example, for deployment, you may define that you just want 4 deployments a day, and you will use when delay and define your start in keyword to specify when you are going to run the deployments. Okay, and with the when keyword, you can also say that you don't want to run a specific job in some cases, or you want to always run it, whatever happened before it, or only on the success of the previous job or on the failure of the previous job, or maybe you want to execute it manually or delayed, as I already said. Okay, so let's define these rules and let's see how to use them. So here is how we are going to not include a job in a pipeline with the keyword never. So basically in that job, what I'm saying with my rules is that if my pipeline is executed from a merge request event, or has been scheduled, sorry, then I don't want to execute this job, okay? And so I'm going through the rules when I'm evaluating them. And the first rule is not true. So I'm going to the next one. It's not true. I'm going to the next one. And the third one is on success. So here I'm saying that you will execute this job only if the previous job has succeeded. Okay. Here, I will have a slightly different approach. And I want my deploy job to be executed only on a manual trigger. Okay, I have run everything. All my jobs have been automated. I have built and tested my application, but I don't want to deploy it continuously. I just want to deliver continuously and deploy manually. So this is when I will use the when keyword with the manual attributes. Okay, in my job, this is what we see here, when manual. And in that case, you will see that specific icon here in your job, defining, okay, this job is manual and no job later in the pipeline will be played until this one is triggered. Okay. And you have also the play, you have of course the play button here to trigger the job. Okay, and another example here is I want to execute the job if this is the exact opposite of the previous one. I want to execute this specific job only if the pipeline source is a merge request or has been scheduled. Okay, so these are the two only rules that I have, and the default will be false, meaning that if none of my rules are okay, then the job will not be executed. Okay, so I will execute only if any of the rules is true. All right. And then the when delayed and start in that we have talked about earlier. Here I'm saying, okay, if my job if my code is committed to the master branch, then I will delay the execution of that job, and I will start in 3 hours, and I will allow failure. So here we see that we can mix the instructions, and the allow failure that was defined at the job level can also be defined at the rule level, meaning that basically I can have another rule here with another if where I don't allow failure. Okay, so in some cases, it might make sense to allow failure on your test environment, but not on your main branch, which will go to production. All right, so you have full control on the execution of your pipeline. You can define whatever you need. And as I said, the default is false. So here I'm evaluating every rule from the first one until the last one. And as soon as one of the rule is true, then I'm doing what the rule implies. And so I'm not evaluating the next rules. So if my CI pipeline source is a merge request event, I will never evaluate nor this one, nor this one. And if the CI source is not a merge request, then I'm evaluating the second one. If none of the two first one are true, then I'm evaluating the third one, and there is no evaluation here, just a when, which is on success, as we talked earlier. All right. And here a slightly more complex one where I can mix things. We have seen that we can use variables, which are $something. We have seen there are some predefined variables. Basically, any variable starting with $CI underscore are defined by GitLab, and you can find them in our documentation. If you look for predefined GitLab variables in Google, for example, you will find a list of all our predefined variables in our pipelines. And here you can also use any variable that you have defined on your side and evaluate them. So these variables can even be filled by your script. No, not by your script, because the rules are evaluated first, sorry. But they can be filled by whatever process you have outside of your pipeline. And then if the variable evaluates to a value, and if some files have changed, so this is what the changes instruction says, look at the Docker file, look at the Docker script folder. If anything has changed here and this variable equals this string, then you will execute that job manually. Okay, you can mix things to really execute the way you want your pipeline and your job. Okay, I'm repeating that the default, if no rules is okay, then the job is not executed. So you can write at the end whenever, but this will be fully redundant because this is the default if no rules is evaluated to true. So I've talked about the variables that you can define, and there is a order of precedence for these variables, and basically with 9 levels. From the highest to the lowest, so from the most important one evaluated first to the least important one. We have all the CICD pipelines, which are the trigger variable, the scheduled pipeline variables, and any variables that you define manually when you're executing a pipeline. You will see that when you execute a pipeline, you have a blue button on the top right corner of your screen saying run pipeline. And when you click on that, you can define a variable. And these are the most important variable for your pipeline execution. Then you have project level variables and group level variables and instance level variables. Basically, we are going from the bottom to the up of your hierarchy. These are variables that you can define at the project level. This is the configuration in GitLab, and you can define them either for your project, for your group, or if you are in self-managed for your instance. when you're using GitLab.com, there is no instance level because they are on our side at GitLab. Okay, then there are all the variables that you have inherited from another environment, which are the .env variables, basically. You are continuing with something less important, which are the variables defined at job level, and then at the level on top of that, which is the global level. So the global variables defined in your pipeline. Then you continue with the deployment variable, and finally you conclude with the predefined environment variables. Okay. And all these variables are given to the GitLab runner when it's run. All right. And the predefined variables are the one that we have just seen, the $CI something. These are the least important for your job. They are available for all jobs provided by GitLab, but they can be overwritten by anything that you have defined manually on your side. Okay, now we have seen the basics of caching, of defining rules, even complex rules, and how to allow for failures. So what we are going to do is to move on to the next section in Instruct. Let's do that. I should be, well, okay. Maybe I will need to scroll down a little bit. So I'm displaying the instructions as I've done earlier with the previous sections. And maybe I leave you some time so you can go through these instructions, and then I will go with you and all the ones who haven't gone through them together. We'll go together.
Thanks, Olivia. And just to cut in there, we are seeing that Instruct is now playing nicely. So for those that couldn't get on, maybe give it another go. But yeah, it looks like it's working a lot better now. Thank you for your patience.
what I would suggest is exactly the same as the previous section. Please raise your hand once you are finished, so we will know when people are finished and we can move on. Thank you. Okay, so I will go through the steps with you all. I've seen many hands already raised. And so we can move on to the next section. So as we have seen, the pipeline may take some time, and what we want to do is to add some cache. This is what we are going to do with that instruction here that I can copy. We are using the commit ref slug as the cache, the key, which basically means that we will have a different cache for every single commit. So if I'm running several times the same pipeline on the same commit, I will reuse the same cache. Okay, I can go here in my pipeline editor and define my cache here. Okay. And then I will add some rules. We have defined that the unit test job, we want to run it only on the main branch. So I will add these specific rules. Here I can go in my unit test here and add the rules. I don't need to add more to prevent it from running anywhere else. By default, it won't run as soon as I've got a rule defined. I will have some failure included. We can add an exit one instruction at the end of the code quality job just to see how things are failing and how we can have the pipeline working even with a failure in the job. So in my code quality, I'm adding a failure instructions, and I will allow failure only for my main branch. So here I'm copying the code once again, and I've said, okay, if I'm on the commit main branch, then I'm allowing failure. Okay, and here you've got the whole piece of code that you have just seen on my screen. So don't need to copy paste that. And here I will commit the change, added some rules to my main branch, and I'm committing. Okay, and now the pipeline will execute. I can see my pipeline here. It's running, and we don't want to look at a screen running a pipeline. We'll see the results later, and we'll move to the next section. The next section is on the next screen. Okay, okay. So now we are going to talk about templates and artifacts, which are two very powerful features of GitLab CI and GitLab pipeline. So now our pipelines for the Tanuki race game is running smoothly. We are pulling things from the cache, so no problem on that. But now we want to take full advantage of the GitLab features like security scanning and sharing artifacts. So the execs are asking us to demonstrate that. Okay, no problem. Let's do that. So here we are going to leverage the usage of the template, and we're going to use the SAST template from GitLab, which is a template that we provide at GitLab, and you are free to create your own template and use them or share them whenever and wherever you want. But we at GitLab provide a set of default templates which you can reuse freely. So basically, what is a template? It's a way to share CI/CD capabilities. Okay, so this is a definition of jobs or even of full pipelines that you can reuse and include in your own pipeline. Okay, this can be your pipeline or the pipeline that GitLab provides. But one thing that is very important is that this is not magic. There is no black box here. These simply are YAML files, the exact same YAML files that you have already played with defining your own pipelines. Okay, these are jobs. These are a set of jobs, a full pipeline, and nothing more. Okay. So there is no magic. You can always look at them, understand them, and update them or override them if you want. Okay. There are 4 types of templates that you can include. Actually, 4 types of include instructions. The include templates to get the template that GitLab is providing to you. The include file to get the template from a file in a project which is in the same group hierarchy. Okay, so you must have a common parent, common ancestor in your project hierarchy to use the include file instruction. You have a include local to reuse a template from your project, basically, somewhere else in your project. And include remotes to pull the code from somewhere else, any repository, anywhere else on gitlab.com or anywhere on your self-managed instance, for example. No problem with that. Okay. So a template, as I said, is defining jobs, and you will see all the keywords that are used for any other job. Okay, and one of the things that you may find are the variables, which might be defined in a job, and the image or whatever, and you can overwrite them when you use your templates. Okay, so here you have a set of variables which are defining a behavior, and you will be able to override them basically in your own pipeline. Okay, so the variables, we have already seen them, but these are basically key and value, and you can reuse the key anywhere with the dollar sign. This is what we have with the $CI for the predefined variables, and with any other variables that we have already seen with the rules. You have these variables, and you can write them when you're using templates. So what is important when you include a template is to understand your template, of course. Okay, so once you have understood it, you can write it, and you can have it behave like you want it to behave. Okay, if we look at the GitLab SaaS documentation, you will find the GitLab SaaS template, which is displayed here with a set of variables. And this set of variables are saying what is the prefix for the analyzer that we are going to use, and what are the SAS that we want to exclude from the scan. Okay, the SAS stands for static analysis security test. So these basically are the type of tests that we want or don't want in the case of the exclusion, that we don't want to run against our code. By default, our SAS template will run all the analyzer that we have at GitLab, and you can exclude some of them if you override the SAS exclude analyzer variable. And if you don't want to run the SAS analyzer on some pieces of your code, you can also exclude some paths. Basically, in this example, the spec test and TMP folder won't be analyzed by the analyzer. Okay. So by default, the SAS will use a pattern matching to decide which language scanner to execute. Okay. But we know that our app at Tanuki Racing is an app developed with Node.js. And so we just want to focus on only using Node.js by excluding everything else, basically. Okay. So we are going to override that SAS excluded analyzer variable that I've just talked about a couple of seconds ago, to exclude all the analyzer that I don't want to use. Okay. So this is the full list of scanners that I want to exclude, and the full list of analyzer that exist is available in the SAS itself. You will be able to see the full list from the documentation. I'm pretty sure one of my peers, James or Sullivan, can share the link to the documentation in the GitLab documentation, which display the full list of our analyzers. So you can have the name of every one of them. Okay. Then we will also talk about artifacts in this section of the lab. The artifacts are pieces that you want to export and made available outside of your pipeline. Basically, if you compare with the cache is shared from one job to all the other subsequent jobs, as long as they use the same cache key. The artifacts are pieces of deliverables, basically, that you want to expose outside of your pipeline, that anybody who has access to your project, of course, can download and retrieve to use outside. And you can download them from 4 places in GitLab, from the pipeline pages that we have seen already. And this is the page where we have all the list of all pipelines. Then if you go in a pipeline, you will have the list of the jobs. And so you can download from the job itself and the pipeline that are exposed by the artifacts that are exposed by the job. And then if you dig inside the job, you can download directly from the detail of your job. You have download button. Here you have the download button that can be used to download the artifact from that specific job. And then you can even browse using that button. You can even browse and see what are the artifacts that are exposed, and either download all of them or download only specific ones. Okay. What is important is that these artifacts are stored on the S3 storage, which is associated with your runners. And so basically, well, not the runner, the instance, and the cache is associated to the runner, and the artifacts are associated to your instance. And so basically they will fill in the space available. And it's important to define an expiry date. By default, all artifacts expired in 30 days, if I'm not mistaken. And you can use the keyword expire in to define something either shorter or longer. You may don't want expiration and keep it forever. The keep button that you can see here in your job details helps you to store that artifact beyond the expiration. So even if you have an expired one, you can keep them for a much longer time. And you have also to keep in mind that's all. Yeah. Okay, you can keep them for as long as you want. Okay, and so now we are going to define artifacts and we use templates in the next Instruct section. All right, let's go there. Next. And start. One, I won't be able to show all steps in my screen at once. Okay, and maybe we can have our first break here and say, okay, let's move on. Let's take 15 minutes to go through these instructions and maybe have a coffee or whatever you want, either before starting this section or once you have finished, as you wish. And let's say we are back at quarter to the hour, if that works for you. Okay, everybody, time's up for the break. I realize I'm not very inclusive because this is quarter past the hour for India. So sorry for my Indian friends here. But everybody's welcome, of course. Just the time's up for the break, whatever time zone you are in. So I will go through the steps. So people who are still on the break can jump in and see the instructions being done, and then we'll move on to the next section of the day. So what we want to do here is to include a pipeline. We will include a template, and we will include a template provided by GitLab, which is our SaaS template. Okay, let's do that in my pipeline editor. I will include that with the appropriate indentation. Okay, I can see here something very interesting with that icon here. I can see that this included two things. This is the SAST security SAST template that I have included, which itself include another template that I can go and see here. This is the SAST template itself that we are going to override partially with all the SAST exclude path, SAST exclude analyzer that we have just seen earlier, okay, that we have just talked about earlier. And as you can see, this is a very basic set of jobs, or very basic pipeline actually, with jobs, image, variables, and all the keywords that we have already seen. So what we want to do is to write a couple of variables here. We want to define the CS Dockerfile path and include some other templates. Maybe before including other templates and before it's got too heavy, we want to go to the full configuration, and here in the full configuration tab, we will see every single thing that is included in my final pipeline. So meaning whatever I have edited on locally and the content of everything that I have imported included as a template. Okay, so I can scroll down, and this is the merge basically of the two files that I have just opened earlier and what I have written here. Okay, and here I want to redefine some variables and add some more templates. With all of that, okay, I will have a full configuration slightly bigger. And I can see that the scroll here is smaller. I have much more code here, 500 lines of code with only 50 defined on my side. Okay, so what I want to do, by the way, all of these templates that I have included are defining specific jobs with their running in their own stages, but my stages right now are only build and test, and I want to add some more stages to run everything that has been included with the pipelines. So let's go here and add the additional stages that I want to run. Okay, and so I can once again go to the full configuration and see what's going on and if the content suits my needs. No problem on that side. And here, what we are going to do next is to override a part of a job. Actually, I want to override the SaaS job and run it in the security stage and run it as soon as possible. So I'm using the needs keywords with an empty array. So meaning that I don't want to wait for anything to have finished before running any of my SaaS jobs. So I'm going to copy and paste that here after my include. Okay, So here I've added my configuration. I can visualize things. I've got security. I've got all my jobs here in the security section. Maybe might be interesting to view without this. Every security thing is in the test stage. And so here I'm defining a very specific stage for my SaaS jobs. Okay, very visual to see this here. All right. And before committing to prevent from triggering too much pipelines, I will add the keyword artifact just to export a piece of my build. So I will change slightly my build app and export the dist folder. The dist folder, for those of you who are not familiar with Node and Yarn, which is the build monitor, say, of Node, one of the build engine for Node. The dist folder is where the deliverables are written when I'm running when I'm doing my build, which is that specific instruction. Okay, so let's copy that build up and change what I have had so far. Okay, so now I'm building and I'm exposing my artifacts in the dist path, and I will drop them in 1 hour. All right, so now I can commit and this will trigger my pipeline automatically. And so we will see the pipeline being executed and the artifacts being available at the end of the execution. Included some templates and post some artifacts. Good, commit change. All right. Normally the pipeline has been triggered. It is. I can see I've got 3 stages now. And as you can see, there is only a subset of the security jobs which are run, and which is basically what I said earlier with the rules. We are running only the jobs which are relevant to the code that we are executing here. And so we are only running the jobs relevant to Node.js. All right, we won't wait for the pipeline to finish. We will see the artifacts later before moving to the next instructions. But let's go back to the slide deck and don't wait in front of a screen like that one. Where is here? So the break time is over, we said, and we move on to the child pipelines. So now that I have demonstrated to the whole team at SaaS Tanuki company at the result of my pipelines, of the templates, other teams in the company are getting curious and are enjoying the power of pipelines, and the security team has defined their own pipelines regarding security, and they would like us to use them. One of the solutions that I'm seeing here is to use a child pipeline to trigger them, and this is what we are going to do. From a real world perspective, this is not necessarily the best use case, but this is the easiest one to demonstrate in a workshop. You would probably trigger a compliance framework or something like this, or some rules that we can set up in GitLab. But from a workshop perspective, it will not fit in the time frame and add some more complexity. So let's keep things simple and just add the security pipeline as a child pipeline. What is a child pipeline, or we should say a downstream pipeline, actually, because it's either a child in a child-parent relationship or a pipeline from another project which is triggered. I mean, you can have multiple pipelines defined in your own repository and triggered inside the same pipeline. So your parent pipeline triggering other pipelines, or you can have pipelines from other projects triggered. Okay, the parent-child pipeline relationship means that both exist in the same project. They run under the exact same references, so every push to the repository trigger both pipelines actually. And the status of the child pipeline does not directly impact the status of the parent pipeline, meaning that as soon as the parent pipeline has finished all of its stages and all of its jobs, its status is displayed, whatever it is, success or failure, even if it has started a child pipeline which is not yet finished. Okay, and you can change that behavior using the strategy depend when you are triggering the child pipeline, in which case you will wait for your child pipeline to finish before displaying the result of your parent child pipeline, which means you are creating a strong relationship between the child and the parent here. The other approach with the child pipeline, with the downstream pipeline, is to have a multi-project pipeline, meaning that each pipeline lives its life in its own project. And the upstream pipeline is triggering the downstream pipeline in the other project. And in that case, you don't have any relationship from one to the other. Okay. There is a limit on the number of child pipeline that you can have. But I can't remember how much. I guess this is 2 or 3 levels of child pipeline in that case. Otherwise, it's becoming too complicated. And in the case of multi-project pipeline, there is no limit because you are just triggering project from other project in other project pipeline in other projects. So there is no limit with the multi-project, while in the parent-child pipeline, you have an hard limit set by GitLab just to make things readable and understandable. Okay. Okay. Once you have some downstream pipeline, upstream and downstream pipeline, you can add some rules to specify what you want to run and what you don't want to run. And basically here we have an example of 3 jobs. The first one is executed only in a downstream pipeline. The second one is executed only with a merge request. And the third one is executed in both. This kind of approach helps you define the exact behavior that you want. Maybe in some cases, when your pipeline is triggered from a parent, an upstream pipeline, you want to place some tests. And if it is triggered with the merge request, then these tests are not relevant at all and you don't want to execute them. So you can fine tune the execution of your pipeline, playing with the rules, even in your downstream and upstream pipelines. Okay, and so let's go back to Instruct and do a child pipeline and see how it behaves. So here is the instruction. Maybe our pipeline is finished. Yes. So if I go back to the pipeline before we move on to the child pipeline, I have set up an artifact on that pipeline and I can download it from here. As you can see, I've got a set of artifacts here and I can download them from the pipeline view. And as I said, you can also go directly to the job which are executing, which are providing this artifact and download them from there or browse them and so on and so forth. But this is all you can retrieve the artifacts from your pipeline or from your jobs. Okay, so they have been provided and we can retrieve them, no problem. executed as expected. And in instruct, let's move on to the next section. Loading. Now is a good time to start. Just one thing maybe for those who have not finished the previous sections. This is something that is written somewhere in here. You can always change the branch you're working on. If you go back to your project in GitLab, we are working in the main branch since the beginning of this workshop. At any stage, you can move on to another branch, which was the name of the section we're working on, and start from that point. Okay, so basically, you can move on to the extended SaaS to the child pipeline. If you have not finished the extended SaaS, let's move on to extended SaaS and build your child pipeline on top of that. Okay, just select the branch which suits your need, and you can see the pipeline from there. Okay, here in the child pipeline, I will see my child pipeline, my downstream here. This is the result I'm expecting once I have finished my child pipeline instructions. Okay, so the previous one was extended SaaS, and I will build on top of that my downstream. All right, I will continue to play on the main branch, but feel free to change the branch so you are comfortable and you can follow the instructions. Okay, I'm leaving a few minutes for you to read the instructions and do them on your side. I have seen someone saying that he cannot find the web, he or she, by the way, cannot find the web IDE button. This is where you will find it. And it will open a web editor, which is basically Visual Studio Code, sorry. On the branch you have selected here. So you can change your branch here and then click on Edit Web IDE, and you will open your code in your editor. Well, I will go through the steps so you can follow. I don't know how many. Yeah. Okay, so I've just clicked Edit Web IDE here to open the Web IDE. And so then the instruction says to create a security pipeline folder. Let's do that. Here I can create a folder named security pipeline, and that pipeline create a security .gitlab-ci.yaml file. Okay. And in that file, copy and paste these instructions. You will see something that you're already familiar with. This is just including some templates that we at GitLab are providing to you. So here is our super useful downstream pipeline, and I will commit it with that button here if you're not familiar with Visual Studio. So I can click here. I'm committing to main. You can select the branch where you want to commit, but I want we'll add the security downstream pipeline added, and I'm committing to main. It's okay for me. So now back here, if I'm refreshing I can see I've got my security pipeline and the code here. No problem. It has been committed. It has triggered the pipeline also, and I can see the execution of my pipeline here. I don't want to take care of that right now. I will move on to the next step. And what I want to do is to connect that pipeline to that security pipeline to the main pipeline that we are using. So with all the stages that we already have, we are going to clean things. We have many includes that we don't want to take care anymore in the main pipeline since we have them in the downstream pipeline. So we'll remove the stages from here. I will remove the include, which are here. Okay, so this will be our base pipeline that I can edit here, build pipeline editor. I will change things to be back to something with less instructions. And at the bottom of that, I will add a downstream security, which will trigger my security pipeline. So you will see the include keyword once again with local instead of template, because we want to use the local file. So local stands for any file in my project. I will add my downstream security pipeline here. And since this is running in security stage, I will add the security stage here. Extra security, sorry. Extra security. All right. So this seems to match the instructions. I did downstream pipeline, and I can commit to trigger the new pipeline. Very good. I can click here on the pipeline and see that I've got my build, my test stages, and I've got my extra security, which will contain all the jobs once triggered. Once again, we won't look at the screen executing the pipelines. We will see the result later after the next instructions. And for the next instructions, well, I guess it's time for me to leave the end to my fellow awesome colleague, Ted. So Ted, the floor is yours.
Awesome. All right, thanks. So first thing, let's see, I'll go ahead and try and share my screen.
Yeah.
All right. Awesome. So just, am I sharing my screen? You guys seeing everything all right?
Yes.
All right, cool, awesome. So with that, before we move on, let's just take a very brief poll and see how everyone feels about the pace of our webinar so far. So internally, if we could just go ahead and spin up a quick poll. Thank you. All right. So let's see, we still got some answers coming in, but it seems so far that the speed, the pace is all right for the most of you. For some, it's going a little too fast, for some a little too slow, but I think then, for me at least, that indicates that I should probably keep up that pace, so I'll do my best to do so. All right, so let's keep going with section 5. Now, to review, so far, Olivier has walked us through setting up our continuous integration pipeline and helped us understand the format of the GitLab YAML file. What we're going to do now is really get into continuous deployment. And to do that, the first thing that we're going to do is set up our Kubernetes agent. Now, just as a reminder here, you really don't have to worry if you fall behind or if this workshop is moving too fast. As mentioned in the beginning, you have access to all of these systems for up to 48 hours, so you can come back at any time within that time frame and continue at your own pace. And feel free to just watch for now. Great. So we've now managed to showcase CI, and we're all in to move forward with GitLab CICD. Now, as the ops engineer, we have to figure out how to connect our Kubernetes cluster to a GitLab project to actually deploy our applications. And so to do that, we've been tasked to get the GitLab agent for Kubernetes up and running. So what is the GitLab agent? Well, think of it as a secure way for our Kubernetes cluster to bidirectionally communicate with our GitLab instance. So for example, it can be used to make sure we have appropriate configurations of our Kubernetes cluster and monitor that configuration. We can use it to deploy our applications through our CI/CD process, and also do infrastructure as code scanning and operational container scanning via the agent that to scan the actual containers in the cluster itself. So we're also expanding on future functionality in here. So looking at observability support, and in the future, additional deployment tooling to support the GitOps flow. Now, when we look at GitOps, there are generally speaking two approaches that can be taken. The more traditional approach is the push-based model, in which you have all the configurations and instructions for your environment defined as code within your repository. Here you would run your CI/CD pipeline and push the changes made to your environment. This approach can be implemented, for example, by leveraging our Kubernetes agent. You also, however, have the pull-based model. Now, with this model, your agent will actually be within your Kubernetes cluster and regularly connect with GitLab and monitor the repository for any changes. If any changes are detected, the agent will be leveraged to apply those changes to your cluster. It also makes sure that if any manual changes were made to your cluster is returned to the state defined within your repository to prevent any drift. So with that, in this next section, what we'll do is configure our agent. We'll start off by configuring our GitLab project to use the agent for Kubernetes. We'll use Helm to install the agent in our Kubernetes environment on GCP. We'll go ahead and create a cluster management project that will be used to install applications needed by our cluster, specifically an ingress controller. We'll continue by running our CI/CD within the cluster management project to install that ingress controller. And finally, we'll configure an environment variable in GitLab to specify the base domain of our integrated cluster. So with that, let's get going. Now, what we see here on the left-hand side is the workshop project that we've all been working on right now. On the right-hand side, I have the current instruct steps opened. So let's go ahead with step 1. Now, the first thing we want to do is we want to go to our project overview and open the web IDE. So let's go ahead and do that. Assuming most of you are on your workshop project right now. If not, the breadcrumbs up top are always a good way to get back to your workshop project. Now from here, we want to open the Web IDE. So the easiest way to do that is by clicking on the Edit drop-down button and then clicking Web IDE. Now, from here, what we want to do is adjust the configurations for our workshop agent. The way we do that is by going to our GitLab folder and then the config.yaml file. Now, the change we're going to make here is on line 16. We can see that at the moment, there's a placeholder. So right now, it's just pointing to a placeholder called path to your group, but we'll want to go ahead and replace that. The easiest way to replace this is simply by going to your navigation bar and copying everything from environments all the way over to the unique string in here. So really environments, the session with that unique ID, and so on, and then copy paste that in here. So it should look like this. I'll go ahead and increase the size. I realize this might be a little small. So this should be the format. Also in the instruct, we can see that this is what it should look like. Please make sure to not have any trailing characters or anything like that in here, as matching this precisely is really important in our case. Great. So we've now gone ahead and configured our agent, and we will continue on with our next section here, which is clicking source control and committing and pushing our changes. So just like before, we'll go over to source control and then click commit to main. With that, our changes have now been committed, and we can return to our project to further register our agent. So go ahead and click to the Go to Project button in the pop-up. And now from here, actually, I will make it a little smaller so that we can still see the menu on the left-hand side here. So what we want to do is go to the next part here, go to the Operate menu item, and go to Kubernetes cluster. So for that, on the left-hand side here, we do see the option Operate. So let's go ahead and click on that. And then scroll down to Kubernetes cluster. Now, what we want to do here is connect our cluster. And to do that, we will go ahead in the top right, we see a button that says Connect to Cluster. We'll go ahead and click on this. Now, if we did everything correctly so far in this dropdown, we should see our workshop agent that we've just defined. So let's go ahead and click on that. And then we click the Register button on the bottom right. Now, what we see here are Helm commands in order to connect to our cluster. So let's go ahead and copy these. You can do that either manually copying them or using the copy command button over here on the right-hand side. And now this is where we're going to go back to our instruct interface. I'll minimize the instructions here so that we can have an overview of the GCP shell here. What we're going to do is simply paste those commands in there and let them run. Now this is going to take a minute. We can see the workshop agent does not exist. It's installing it now. And once this is complete, we can move on. So opening step 2, we're being asked to, let's see here. There we go. Navigate back to our GitLab tab and close the pop-up. So we're going to check the connection status just to make sure that our agent is connected. Easiest way to do this is by clicking the X in the top right or by clicking the close button in here. And we can see at the moment it's not connected. However, if we refresh, fingers crossed, sure enough, it's connected in here. Not sure why there are 2 in here, but as long as we have one, we are all good to go. So with that, let's see. So we have the connection status as connected. Now, the next thing that we want to do is go to our workshop group. Now, the easiest way to do that is, again, by going up to the breadcrumbs. For me, I can see the My Test group with our unique string up here. If you don't see it, you can always expand the breadcrumbs by clicking the button up top. So again, make sure to click on the My Test group button link, and you should be able to now see this overview in here. And what we want to do next is create a GitLab cluster management project. And so in order to do that, we'll go ahead and go to the third part here, or let's see, rather the second part. So click on New Project and create from template. So all we're going to do is click the New Project button on the top right. And we are going to, as mentioned, create from a template. So go ahead and click on that button. And the template that we're looking for is the GitLab cluster management project. So for that, scroll all the way down, and you should see it fairly close to the bottom. So it's the 1, 2, 3, 4, 5, 6th template from the bottom, called GitLab cluster management. And in order to use this template, all we have to do, go to the right and click the Use Template button here. The only thing that we're going to add in here, as described here in the third section, is cluster management. We're going to change that name, or rather add that name. So I'm just going to copy paste that to be cluster management. Leave everything else as is, and we'll create the project. Now, this will go ahead and import that repository for us. Should usually take a couple of seconds. Yep, sure enough. All right, so we see this now in here, and we have our cluster management project that we can leverage now. So next thing that we're going to do is go to the project overview, which we're already at. And we'll, again, open the web IDE. So the same thing as before. We'll go ahead, make sure that we're on the cluster management overview page. If you're not on this, you always have the option on the top left just to click project overview. And from there, again, clicking the edit dropdown option and click on web IDE. Now, the change that we're going to do here is in the helm file.yaml on line 19. And so let's just go to that. The helm file.yaml is in the root here. Just go to line 19 and uncomment this. So this really addresses our ingress here. So with that, we'll go ahead and click source control and commit to master. We'll go ahead and click the continue button from here. And with that all out of the way, we'll head back to our project. Now, what this did is it kicked off a pipeline. So let's go ahead and take a look at that pipeline. The easiest way to get to that is by going to the left-hand side to the build section, and then going to pipelines. Now, what we see here is a pipeline that was just kicked off. If we take a look at it, we can see it's basically running 2 jobs at the moment. It's basically kicked off a diff job in here, which we're basically going to wait until it's done and then manually run synchronization in here once that option is available. So this usually takes about a minute or so. So let's just go ahead and wait for that to finish. And sometimes it helps to refresh the page. The UI sometimes is a bit slow in updating here. There we go. So now our first job has run, and we will go ahead and manually press the sync button and also wait for this job to finish up. Should be done in just a minute. And once we're done with that, we can actually go ahead and deploy our application here in the next step. Again, using that GCP shell. Let's see. I'm also seeing one comment in the chat here about GCP shell not working. I hope this is not a widespread issue. I hope everybody's able to still continue on. All right, there we go. So now everything has finished, and we can go ahead and continue on with step 3, final part of this section. And so what we want to do is go back to our GCP shell. And the first thing that we're going to do is run the following command here, and simply copy it and run it again within the GCP shell opened in instruct. What we're looking for is the external IP. And sure enough, if we look at the Ingress Nginx controller, we can see external IP has been generated. So this value we will need in just 1 second. So I'm going to minimize this again as we need to go back to our GitLab interface. And what we're going to do from here is navigate back to our GitLab tab. So we're on that, and go back to our group section. Now, we're going to do that by clicking the breadcrumbs up here and making sure that, again, we are within the group level, not the project level. So this is roughly what you should be seeing here, our workshop project and our cluster management project inside of our test group. Now, what we're going to do is add a custom CICD variable in here. And so for that, we're going to go to settings on the left-hand side here, expand that, and then head down to CICD. That completes part 4. And let's go to part 5, which basically asks us to add a variable in here. So for that, we can just go to the variable section. On the right-hand side, we see the expand button in here. Let's go ahead and click on that. And we can immediately see we do have the add variable option up on the top right here. So again, let's click on that. And now we have the option to add a variable. Now the name of the variable is here in instruct, so we can find that cube ingress base domain. We can simply copy this, head back over to our GitLab instance, and paste that as the key. Now for the value, it's a combination of the external IP and the rest of the string here. So what we're going to do is go back to our shell. Let me see, I just got to make it a little bigger so I can see that external IP. So yeah, go ahead, copy this, and paste that in here. So this is roughly what it should look like on your end. Your external IP will be different. However, the name and the trail here at the end should be the same. And we can go ahead and disable the flags in here. So making sure that protect variable and mask variable are disabled. Now with that, I'll go ahead and click add variable, and we should be done with this section. So let's see here. Before I jump in, I see if we have pending in the external IP. The easiest thing is just rerun the command. For me, after a while, I do see it pop up in here again. That should be it. Right. So all right, let's see here. Give me 1 second. I'm just seeing that I might be going a little fast here. So basically what we're trying to do here, we have set up our agent, registered it, and at this point in time, basically what we're doing is we're just getting the external IP in here. So again, if you are running into this issue, what you can do is copy the command that we can find under step 3, part 2. Just copy that, paste that in there. And again, you should, when looking at it, see under ingress nginx controller, the column external IP. And so that's what you're going to go ahead and copy. And again, I'm just going to click the edit button here real quick. Got to make sure that that external IP is the initial part of the value in here. And the name as described here in part 5 is cube ingress base domain as is. All right. So with that, we've completed this section. I'll go ahead and spin up the next instruct. But before that, let's go ahead and briefly talk about auto DevOps and containers. So far, we'll go ahead and take a look at auto DevOps next. And just to review, we've set up our agent at this point in time, which allows us to connect with our Kubernetes cluster. So now we're at a point where we are actually ready to deploy. At this point, we will go ahead and run a quick deployment test to then iterate on top of that before defining our own custom pipelines further down the line. For this, what we're going to do is leverage auto DevOps, which itself leverages GitLab out-of-the-box templated jobs to get everything up and running quickly. In the future, we can also just include specific templates for the jobs we want in our own custom pipeline. Now, what we're going to do is run this in instruct and then come back while our pipeline is running. So go back to our interface here, and I will click the start button to head over to our final section over here. Now, as mentioned, we want to enable auto DevOps. So what we're going to do is head back to our workshop project and then go ahead and adjust the settings to really enable auto DevOps in this case. So for this, what we're going to do is go back to our breadcrumbs and click on the group. So my test group in here. And then from here, we basically just want to go back to our workshop project. So now that we're in our project, as mentioned, we want to go ahead and enable auto DevOps. So for this, as mentioned here, we'll go to Settings and go to CICD. We'll go to Settings, and then we see the submenu option, CICD. Now from here, we already see the Auto DevOps option. So let's go ahead and expand this. We can see it's disabled as of now. So what we're going to do is click the checkbox, making sure that default to Auto DevOps pipeline is enabled, and click Save Changes. Now we see a couple of options for deployment strategy. And we're just going to go ahead with the first one, continuous deployment to production. Again, clicking the Save Changes button. Now, that enables Auto DevOps, but what we want to still do is go ahead and do one more change to the variables. So this is going to be in part 3. We're going to scroll down, expand the variables section, and then add a variable that disables tests in here. So again, we have variables here as a menu item. If we just scroll down a little bit further in that same CICD sections, that settings section, and click the expand button, click the add variable button, and copy paste test disabled. The value we're going to set to true and make sure that both the protect variable flag and the mask variable flag are disabled. The idea here is that although we're using an out-of-the-box Auto DevOps feature, which runs a variety of different scans and jobs for you, we still have the option to customize this. In this case, for example, by simply adding a variable that toggles the test job in here. So with that, we'll go ahead and add our variable. Now, what we're going to do next is go back to our project overview, because there are a couple of changes that we still need to make sure that Auto DevOps actually runs. So for that, the easiest way to get there is going to the top left and clicking the project overview menu option. From here, we're going to make a change to a file, specifically the GitLab CI file. The reason behind this is that Auto DevOps will only run if there is no GitLab CI YAML file, so if there are no pipeline definitions in here. So what we're going to have to do is basically disable the pipeline that we've set up so far. The way to do this is, again, by opening our web IDE. So again, clicking on that edit dropdown option and clicking Web IDE. Now, the easiest way to indicate that we don't have any pipeline definitions in here is by simply changing the name of our GitLab CI YAML file to, in our case, in our instructions, it is the whole.txt file name. So again, this is basically just a placeholder. And the way we do this is we right-click on GitLab CI.yaml and then scroll down to rename. In our case, I'll change the name, as mentioned, to hold.txt. And that should honestly do it. So if we go ahead now, and as mentioned in part 5, click source control, and then commit and push our changes. Let's go ahead and do that. Click source control. Click the commit to main button in here. And we go back to our project. Easiest way of doing that is, again, going down to the pop-up that appears in the bottom right-hand side and clicking the Go to Project button. Now, we can already see indicated up here that a new pipeline has been kicked off. So let's go ahead and take a look at that. Again, as mentioned in part 5 here, by clicking the build menu item and then the pipelines submenu item. Go to the left-hand side here, we have the build menu item. So by clicking on that, we can expand that. And then heading to the pipelines submenu item. Now we can already see pipeline kicked off a bunch of new stages. So let's go ahead and take a closer look at what's happening here. And sure enough, let's expand this a little bit so we can get a closer look. We can see we have a variety of very different jobs that are being run now compared to what we previously defined in our first part of this workshop. And now this pipeline is going to take a couple minutes. So while this is running, let's quickly jump back to our slides to discuss and go over what we're seeing here. So think of this as basically just GitLab using an end-to-end pipeline and using various different pipeline templates under the hood. So basically what we see here in AutoDevOps are a variety of different jobs and stages. And generally speaking, we will have a build stage, which detects the project's language and will build based on that. We have a test stage, which runs a variety of app security scans and unit tests. We have a review app, which will deploy for a branch and launch the app from an ephemeral environment. We also have the option to add a staging job in here, which will deploy a staging environment for QA and regression. We have the option to add a production stage, which will allow, for example, for incremental rollout, manual deployment, or auto deployment options. And finally, we also have a performance stage, which will run browser performance tests. So when setting up AutoDevOps, you also have the option to define different deployment strategies. These include auto deployment to production, incremental rollout, or deploying to staging automatically, however, then deploying to production manually. As we've seen already previously and indicated previously, you have the option to define custom variables, which can have an effect on this as well. So for example, when looking at incremental rollouts, you can define if these should be manual or timed. The default for time, for example, is 1 minute. However, if you also define additional variables, you can go ahead and adjust this as well. You can also define a variable to enable staging, for example, which will then also require a manual deployment to production, no matter the deployment strategy. Now, the templates used by the AutoDevOps feature are all also available individually. So you can just add any jobs you've seen in the AutoDevOps pipeline to your own custom pipelines in the future. You can also view the exact pipeline definition of AutoDevOps to help you create your own custom pipeline based on AutoDevOps. And that's basically what we're seeing here. So here are a variety of different templates that AutoDevOps really uses under the hood, all by leveraging the include statement. So in the future, if you were to decide to add, for example, some security scans, all you'd have to do is add the include option in here, and then the appropriate template. So for example, we could add template container scanning, dependency scanning, DAST, browser performance testing, and so on. So with that, I think our pipeline is still running. Let's just take a quick look. I'll go ahead and refresh the page here. All right, so it's not entirely finished, but we can see it already progressing in here. We've finished the build and testing stage, and our app looks pretty good so far. And right now, it's just spinning up a review application, so ephemeral environment to run DAST on, and then moving on to production, performance, cleanup stages, and so on. Now, just keeping an eye on the time, I'm not going to go into detail into this and wait until this entire pipeline is finished. But I will address really quickly still the topic of GitLab registries. So GitLab does provide its own package registries to publish and share packages that can be consumed as dependencies in your downstream projects. Registries are available for a variety of common package managers such as Maven and NPM. And we also provide dependency proxy. So this allows you to use GitLab as a source for your Docker images when they're stored on Docker Hub by caching the Docker images on local GitLab container registries, so that a second invocation of that image will be picked up from the local registry instead of Docker Hub. You can, of course, also use GitLab Docker container registry to store Docker images that are used for your jobs. Now, the last section in this workshop, we're not going to go into detail here, which is transferring your project. That being said, you do have access to all of this for 48 hours. So with the instructions that you do have in Instruct, you can go ahead and do this yourself. That being said, it is very important to note that everything that we've seen here was with a GitLab Ultimate license. So if you do transfer to another environment that you might have that doesn't leverage the GitLab Ultimate license, you might not be able to leverage all the features and functionalities that we've seen here. And one thing to just mention, I always like to bring this up, you do have access to all of GitLab Ultimate for that time period. So that doesn't just mean you have to play around with this. GitLab has a variety of really interesting features and functionalities that you can play around with. So for example, our most recent AI features like code suggestions are available to you within that time period. So please